Hi, I'm Malavali, Assistant Professor in the Department of Computer Science and Engineering. Now, we are going to discuss about conversion from NFA with epsilon to DFA. NFA is nothing but non-deterministic finite automata and DFA is deterministic finite automata. Now, we are going to see the steps for converting NFA with epsilon to DFA. In the first step, we'll find the E-closure for each state of NFA so that we can draw it for DFA. In this, for each state, we'll find the transfers of the state with each input. Next, if we find any new state, we perform the step 2, which is nothing but we'll find the transfers of the present state. Next, we'll be keep on continuing the step 2 and 3 for the new state until we do not find any new state. Next, we finalize the DFA and for that DFA, we'll draw the diagram. Now we are going to see an example problem for NFA with epsilon to DFA. Here is our problem. Here we have the state Q0, Q1, Q2 and the input are 0, 1 and 2. Here we need to draw the transition table. For Q0 of 0, it goes to itself. For 1, it is empty and for 2, it's empty. And for Q1, for 0 input, it's empty. For 1, it goes to itself and for 2, it's empty. And Q2 for 0, it's empty and for 1, it's empty and for 2, it goes to itself. After we have drawn the transition table, we need to find the E-closures. E-closure of Q0 is Q0, Q1 and Q2. It starts from Q0, it goes to Q1 and Q2. And for E-closure of Q1, it's Q1 and Q2. It starts from Q1 and it go to Q2. In Q2, there is no empty state. So, we'll draw its own state as Q2. Closure of Q0, we got Q0, Q1, Q2. We'll call it a new state A. Next, delta dash of A comma 0. That is for the new state we need to find for each input 0, 1 and 2. We'll write E closure of sigma of Q0, Q1, Q2, comma 0. Next, we'll put sigma Q0 of 0 union Q1 of 0 union Q2 of 0. Next, as we see in the diagram, Q0 of 0 is Q0 and 1 is empty and 2 is empty. So, we'll write E closure of Q0, which is nothing but Q0, Q1, Q2, which is this itself state A. Now, we need to find for the input 1. We'll write E closure of sigma of Q0, Q1, Q2 with the input 1. Again, when we merge Q0 with 1, Q1 with 1 and Q2 with 1, as we see in the table, Q0 of 1 is empty and Q1 of 1 is Q1 and Q2 of 1 is empty. So, we'll write E closure of Q1, which is Q1 and Q2. We'll write this state as the new state B. Now, for the new input 2, we'll write E closure of Q0, Q1, Q2. Again, we'll merge each with the input and we'll check in the table. Q0 of 2 is empty, Q1 of 2 is empty and Q2 of 2 is Q2. Then the E closure of Q2 is Q2. We'll call the state as the new state C. For the new state B, we'll be continuing the each process. We are going to see for the new state B. A sigma dash of P comma 0 will write E closure of Q1 comma Q2 with the input 0. For the input 0, we'll see for q1 comma 0 it's empty and q2 comma 0 is empty. So we'll write empty. Then we'll check for the input 1. We will write the e closure q1 comma q2 of 1. Then we'll see with the table q1 comma 1 q1 comma 1 is q1 and q2 comma 1 is empty. So we'll write e closure of q1 which is q1 comma q2 which is the state B itself. Now for the input 2 again we'll write q1 comma q2 with the input 2 and we'll check in the table we get q2 and e closure of q2 is q2 which is the state C itself. Now we are going to do it for the new state C. Here the sigma dash of C comma 0 will write e closure of sigma of q2 comma 0 which is empty. So we'll put as empty. For the input 1 again it is empty. For 2 when we see in the table we get q2. Now, as we do not get any new state, so we will finalize each state. For sigma dash of a comma 0, we got A, that is Q0, Q1, Q2. And for the input 1, we got B, nothing but Q1, Q2. And for the input 2, we got C. And for the state B, when for the input 0, it was empty and for the input 1 we got B itself, that is q1 q2, and for input 2 we got C, that is q2, and for the state C when the input is 0 it was empty and for its 1 it was empty and for 2 we got itself, that is q2C. Based on this, we are going to do the last step, which is nothing but the transition diagram. Here we have three state A, B, C. We'll put our three state A, B, C. For 0, it goes to itself. For 1, it goes to B. For B, as it is empty, we will leave it. For 1, it goes to itself. And for 2, it goes to C. And C, when the input is 0, it's empty. And 1, it is empty. For 2, it goes for itself. This is the method to convert NFA with epsilon to DFA. Here we have removed all the epsilons and we have drawn the DFA diagram. Thank you.